Hello friends, I am Professor B.Thakur from Terna Engineering College, Dharashiv welcomes you on my YouTube channel for another session of this digital communication technique. As far as our today's session is concerned, so as you can see, we will try to learn this another pulse modulation scheme whose name is nothing but delta modulation, right? As far as our previous session is concerned, belongs to this digital communication phenomena. So we had discussed the first type of pulse modulation scheme in our last session, whose name is nothing but pulse code modulation, right? So basically, as far as this digital communication is concerned, there are n number of pulse modulation schemes we are having with us. Out of that, the second one is nothing but what? It is the delta modulation technique, right? This delta modulation technique is being preferred over this pulse modulation scheme. Whether it is delta modulation or the pulse code modulation system, both these two systems are being exclusively defined for the source encoder in case of this basic digital communication link, to encode the each and every symbol emitted by that information source towards the source encoder, whether it is statically dependent or independent, right? Now, as we know, we are very much aware of this thing. Pulse code modulator will try to assign a finite binary bit code word belongs to each and every sample. Once that code word is being assigned, then after that, that sample is being transmitted on that transmission line, right? By the process of serial to parallel and parallel to serial conversion, which we are discussing last lecture, right? So the objective behind this delta modulation technique is what? That we need to understand first. It is being preferred over this pulse modulation or pulse code modulation technique because the unique identity belongs to this delta modulator is nothing but what? Most of the time, as you can see, this is the overall structure for delta modulator and demodulator, right? And these are the desired waveforms, and some mathematical treatment we do have with us belongs to this delta modulation scheme, right? So as far as this delta modulator is concerned, as you can see in this transmitter block diagram, we are having n number of finite blocks we are having with us, right? So this delta modulator, that can be called it is as a one bit quantizer. That is the unique identity belongs to this delta modulation scheme. Means as compared to the pulse code modulation, as I told you earlier, the transmission bandwidth and the signaling rate or the transmission power, these are the important resources as far as the transmission is concerned, right? So in order to effectively utilize the transmission bandwidth or in order to improve the signaling rate, right? Signaling rate is nothing but what? How many number of bits per second we are supposed to transmit from source to destination, right? So by reducing the number of binary bits, those are being required to replace each and every sample. Obviously, we can improve the transmission bandwidth. Otherwise, or also we can save the transmission power, which is required to transmit each and every sample. If the number of bits those are being taken by that encoder to replace each and every sample is being reduced. So obviously we can improve the bandwidth as well as power, which is done by this fellow whose name is nothing but what? This delta modulator, right? So let us quickly go through this transmitter as well as receiver or modulator and demodulator in case of this delta modulation scheme. So first, as you can see, this is the delta modulator and this is nothing but what? The demodulator. Right. Now as far as this modulator is concerned, so within this modulator we are having finite blocks such as a one bit quantizer we are having with us, and one more block we are having with us which is denoted by this term called as a delay, right? Some sort of delay is being added within that present sample as far as this delta modulator is concerned, right? So as you can see here, so let us quickly go through the functionality belongs to each and every block in case of this modulator and demodulator, right? So as you can see, this is x of NTS is nothing but what? The input which is given to this delta modulator. NTS means what? Obviously it is the instantaneous value, means those signals are being emitted by that sample and whole circuitry, right? These sampling instants are being defined by that unit impulse function, because this is the basic process of this term that can be called it as a sampling, right? So x of NTS is nothing but what? The instantaneous value of that continuous time signal. Means it is being converted into discrete time signal. So first of all, we are having one type of signal adder, or we too can say that subtractor here, right? So here we are having one signal adder, and here also we are having this signal adder. So there are two mathematical adder we do have with us in case of this delta modulator. So one of the input of this adder is nothing but what? The sampled input x of NTS, right? At the same time, as you can see with the help of this certain mathematical statements, clearly we do can understand the working phenomena of this delta modulator, right? So basically, as you can see here, the first statement which is written on that board is nothing but it is E of NTS. E of NTS is nothing but what? The output of this adder. We do can say that. How that E of NTS is being generated? In order to generate this E of NTS, we require the two different types of test signals. Out of that two test signal, one is nothing but what? X of NTS, the sampled value of this continuous time signal. And as you can see, the another input here which is being given to the lower terminal of this adder, that is nothing but what? X cap of NTS. What it is? It is the X cap of NTS. Now the question arises, what is X cap of NTS, right? So one by one we will try to discuss the terminology belongs to each and every abbreviation here, right? And finally this is nothing but what? The output of this delta modulator. The output of that delta modulator will be what? It could be either plus or minus delta, right? Which is we do can learn how that plus or minus delta is being produced by this delta modulator with the help of the signal representation here. So laterly we will try to discuss this one. So first, as you can see, E stands for what? The error. The error present at that particular sample, which exactly equals to how much? How those error signals are being generated? It is the difference in between x of NTS and x cap of NTS, where x of NTS is the present sample value or discrete time signal as compared to continuous time signal, and x cap of NTS. Now the question arises, how this x cap of NTS is being generated, right? So x cap of NTS, we do can call it is as the previous sample of the staircase approximated signal, right? Means from this graphical representation, as you can see, this is the signal which are being shown with this yellow color, that is nothing but what? Our continuous time signal x of t, the envelope which we are interested to transmit. So basically what this delta modulator will try to do here, it will try to map this continuous time signal with the help of this step signal, right? And during each and every signaling interval, it will come to know ki if the difference is positive, then at that time what will happen? The step size is being incremented by plus delta. If the difference is negative, at that time the step size is being decremented by minus delta. So in this way it works as a one bit quantizer, so it will produce either plus delta or minus delta. It depends upon what? It depends upon the amplitude of this difference signal, right? Now where we are getting this difference signal? The difference signal is denoted by what? Here the output of this delta modulator is nothing but what? It is the B of NTS, right? Means each and every sample is being encoded with respect to binary 1 or binary 0. So how it is to be done? Now as you can see, initially see within this signaling interval, the waveform which is shown with this pink color is nothing but what? The step signal, and the waveform which is shown with this yellow color is nothing but what? Our continuous time signal. So during this signaling interval or during that much amount of time, basically what it is? It is the plot in between amplitude versus time, right? And this is the desired decoded sequence generated by this delta modulator. Our area of interest is to know how that sequence is being generated, right? So that sequence is being generated by comparing these two signal level during each and every signaling interval. Which two signal level? The step signal and the continuous time signal. If the magnitude of this step signal is greater than this continuous time signal, as you can see, so at that time we will come to know that this B of NTS equals to minus delta, right? Means if the difference is negative, that negative difference is being encoded with this minus delta. This minus delta, how it is to be represented? It is represented with the help of binary 0, right? Now during this next signaling interval, now one more time these two signals are being compared with each other. As we will come to know ki the magnitude of this step signal is lower than this continuous time signal during this signaling interval as compared to the first interval. So at that time the desired difference is positive. The difference is nothing but what? The difference is nothing but in between x of NTS minus x cap of NTS, and here x cap of NTS is nothing but what? The desired step signal, and x of NTS is nothing but what? The continuous time signal, right? So during each and every signaling interval, the B of NTS is nothing but what? The output of this delta modulator. Here we are getting this signal. So B of NTS, it could be either plus delta or minus delta. Means in this way, each and every sample is being encoded with respect to 0 or with respect to 1. How that modulator will come to know that sample is to be encoded with respect to binary 0 if the difference is negative. The difference in between which two signal level? The difference in between the instantaneous value x of NTS and the previous sample value of the staircase approximated signal denoted by this x cap of NTS, right? So during each and every signaling interval this is to be done, and accordingly that difference is being encoded with respect to 0 or with respect to 1. So this is how this delta modulator will work, right? Now coming back to this x of NTS, as I told you earlier, let us quickly go through the working phenomena of this delta modulator as well as demodulator, right? So in case of this modulator, now it is clear, this is the 1-bit quantizer, means that the difference signal is being encoded by this 1-bit quantizer in terms of plus delta or minus delta, denoted by this signal level B of NTS, right? Now our area of interest is to know how this x of NTS is being generated, right? So as I told you earlier, x of NTS is nothing but what? It is the previous sample value of staircase approximated signal. So in order to get the previous sample value of this staircase approximated signal, we are very much aware of, or we should very much aware of this thinking, what is the present sample value of the staircase approximated signal, right? So usually in case of this discrete mathematics, this step signal is denoted by this function called it as a u of t, a unit step function, right? So here as you can see, the present sample value of the staircase approximated signal is denoted by u of NTS. This signal level is being given to this delayed block, right? So what this delay block will try to do, in order to generate this x of NTS, it will try to add a certain time delay within each and every sample, right? Here TS is nothing but what? This TS is nothing but what? It is the reciprocal of frequency, right? TS stands for, it is the sampling interval, which will be the reciprocal of the desired sampling frequency. So according to this Nyquist criteria or the Nyquist rate, the sampling frequency, it should be how much? This Fs, it should be greater than or equal to 2 omega, where omega is nothing but what? The highest signal frequency component which is present within that envelope. So that much amount of delay is being added to which signal level? To the present sample value of staircase approximated signal to generate the x cap of NTS. So as you can see here x cap of NTS is nothing but what? How we are getting this x cap of NTS? By adding a certain time interval with respect to this u of NTS. So obviously it will become u of NTS minus 1, right? And in this way, either we are getting this plus delta and minus delta as far as this receiver is concerned, right? So this entire receiver, that can be treated as a one accumulator, right? Accumulator basically is being utilized by this DM transmitter as well as receiver or modulator and demodulator in order to generate the staircase approximated signal, right? That is the task allocated to this accumulator, right? Now one more time we are having such type of signal adder here, right? So what this comparator or adder will try to do, it will try to add these two signal levels, right? Which two signal level? One of the terminal of this adder is nothing but what? The input signals or the signals those are being generated by this delta modulator. What kind of signal level is being generated by this delta modulator? Either plus delta or minus delta. Plus delta is denoted by binary 1 and minus delta is being denoted by binary 0. So it could be either binary 1 or it could be either binary 0, right? So what this receiver will try to know, the ultimate function which is assigned to this receiver is nothing but what? After this LPF block, LPF is nothing but what? The low pass filter, right? Whose cutoff frequency is exactly equals to how much? Omega hertz. So omega hertz will be what? The maximum signal frequency component which is present within this yellow signal level. That is nothing but what? Our information bearing signal or the modulating signal x of t. By means of this delta modulator, each and every sample is being converted into either binary 1 or binary 0 and it is being transmitted. Now at that receiving end, what we need to do, from the desired sequence of this 1s and 0, we are supposed to reconstruct the envelope of that modulating signal. So this is the function allocated to this delta modulator receiver, or this is the function which is allocated to the delta demodulator, right? Here delta, why it is being called it as a delta modulation? By taking into account this function called it as a delta is nothing but what? The step size, right? By an amount of either plus delta or minus delta, that step signals are being either incremented or decremented by this delta modulation scheme, which is furtherly encoded as a binary 1 and binary 0. So for what purpose all those things are to be done? In order to improve the overall transmission bandwidth as well as in order to effectively utilize the transmission power. So this is the objective behind this delta modulator. Now as far as this delta modulation scheme is concerned, again there are 2 or 3 certain disadvantages we do have with this. Undoubtedly it is the better scheme as compared to the pulse code modulation, right? Undoubtedly we are improving the transmission bandwidth as well as transmission power. But what will happen in practical scenario, sometimes this step signal are not able to follow the envelope of this continuous time signal. Means if the slope of this continuous time signal is very high, like this, see, if the slope of this continuous time signal is very high, so at that time what will happen? This staircase approximated signal will fall behind this continuous time signal. So due to this, what will happen? Such type of distortion we are getting, and that distortion is nothing but what? We can call it as a slope over distortion. This is the major disadvantage of this delta modulation scheme, right? Practically, if the slope of this continuous time signal is very high, it could be happen practically. So at that time, this step signal will falls behind this, or it will not able to strictly follow the envelope of this continuous time signal. So at that time, such type of distortion can be called as a slope over distortion. So this is the one of the disadvantage of this delta modulation scheme. So to improve this disadvantage, we are supposed to use another enhanced pulse modulation scheme, whose name is nothing but what? Adaptive delta modulation. So hopefully in next session we will try to discuss this scheme, adaptive delta modulation. For this today's session, we have discussed the working functionality of this delta modulator as well as demodulator with the help of the signal representation, and few mathematical statement we do have with us in order to understand the overall functionality of this delta modulation and demodulation. Thank you.